Hi, this is Mr. Conti, and we're going to go over Unit 2 Worksheet 5 today. These are great examples of the various types of tools that we use to describe motion, from position time graphs, velocity time graphs, and motion maps. Also, knowing how to describe motion, what phrases to use, and what information you can pull from some of the given descriptions that we have. So we're going to just get going here. So in the first example, we're given a position time graph. So what we can say from that are a couple of things. So these are qualitative descriptions, so we don't have much in the way of numbers that we can use and calculations to do. But what we can say is that the origin right here, that this location is its initial position at time 0, and it's some positive position away from the origin. The object is moving to the right from where it starts in a positive direction, and it comes to a stop, and at some point in time in the future begins to move in a negative direction, and what it appears to be here is a little bit steeper, so we would say that it's moving just a little faster. So just to be clear, this just means a positive initial position, so that's where it starts. It's moving at a slow pace in a positive direction. It comes to a stop, and then it moves at a faster pace in a negative direction. So now we want to translate that into our various other forms of description, which include the velocity time graph. So this first segment here is a positive slope, zero slope, negative slope. All the positive slopes go up here. Zero is on the axis, and the negative slopes come down here. Since we don't have exact values, you just have to look at the lines that we draw relative to each other. So because for the first period of time the motion is constant and positive, it's going to be up on this in this first quadrant, and we draw a horizontal line to indicate that the velocity isn't changing. Okay. Now we're going to drop this to 0, so it's going to be on the t-axis for about the same amount of time. And then because this is negative, we're going to drop below the t-axis, but seeing that it's a little steeper, we'll extend the graph further below t-axis. The further you are away you are from the t-axis, the faster you're going. So you can't go slower than 0. So whether you're close to the t-axis above or below 0, you're moving slow. The further you are away from 0, the faster you're going. For the motion map, the initial positive position indicates that we should start our first dot placed some positive position away from the left. So as we talked about in class, this far left location, unless otherwise stated, is x equals 0. So we're going to have our first position some distance to the right of x equals 0, and with this being a slower type of motion, we'll indicate that with some small arrows to the right. Where this is qualitative and we don't know how much time this is lasting for, we want to at least draw 2 arrows consecutively that are the same length to show that the motion that it had during that period was constant. Then to show that it was stopped, we have a few dots that represent some moments in time that have passed where the object remains at this location away from the origin. So time keeps ticking on, and we don't want to overlap the dots, so the convention is to start close to the axis, the x-axis here, and then stack away. So let's say at this next moment it begins to move back towards where it starts, but it's going to be a little bit faster, so our arrows are going to be slightly longer, and you can see that it's taken us past where we started, and that's clear that this position is lower than where it initially started. So that's our motion map. So in the next problem, we're given a velocity time graph. So again, we're able to say things like how fast relative to each segment and in which direction. So we know that with this big gap between 0 and the graph, that this object is moving fast as it's moving to the left in the negative direction, as compared to this motion, which is slower but to the right, and then it comes to a stop. Okay, so let's look at the position time graph now. Now, the first issue we're going to run into is in our initial description that the object is moving fast in a negative direction. That doesn't tell us anything about where the object is relative to x equals 0, relative to our origin. So you have the freedom to pick where your object begins its motion. Now, given that I've drawn here the positive quadrant of the graph, and knowing that the object is going to move to the left, which on this graph means that it's moving downward, would sort of lead to the fact that we should probably start our graph up towards the top. That way our graph will be moving down and we have the space available to use. But there's nothing to say I can't place this dot higher or lower or even at the origin and have it drop below the t-axis. Any of those would be acceptable. It's the shape that follows, how you slope your lines, whether it's going up or down. That's what's important. We don't know where the object starts. So just pay attention for extra details. If you're told where it starts, then it sort of sets the problem, that situation in stone. So what I do want to show is that for a period of time, the object experiences fast motion in the negative direction. So this line not only will go down, but it should be fairly steep. Okay. Now we have a quick turnaround, so we're going to now move in a positive direction, but at a slower pace. So our graph is going to go up, but not quite as fast. So our slope should be much more gradual. And then finally it comes to a stop, so our slope actually becomes 0 and flattens off. So no matter where you place this initial point here, everybody should get a graph that resembles this shape. Now what I will say is that because we've chosen this location on our x-axis here, then on our x-axis here we have to also make sure that they agree. So the fact that I started it way off to the right here, I'm going to place my first dot way off to the right as well. Right, now these first set of arrows, being that they're fast and negative, are going to be pointing to the left and rather long. Again, 2 arrows gets me insight into the fact that the object's moving fast. And then it's going to be moving back to the right at a slower pace. So I'm going to bring my next dot up here, and I'm going to draw arrows to the right that are smaller. And then finally the object comes to a stop. So placing a few dots that's stacked up shows that the motion is constant for a while where the object doesn't move. Okay, moving on. The third example. So we're given a position time graph. So this object begins some positive position away from the origin. And if you look at the whole graph, the entire motion is negative. So all the velocities are either 0 or negative. So it appears as though it's not moving quite as fast in this first segment, and then with the graph being steeper here, is moving faster. So positive initial x position, slow pace moving to the left in negative direction, it stops and then returns back moving in the negative direction at a faster pace. So we want to show that most of the velocity time graph is going to fall below the t-axis, where we have our first horizontal segment of constant motion closer to the t-axis. Then we're going to go up to the 0 where there's no slope, no motion. And then with the faster motion, we're going to drop further down beneath the t to show that it's moving with a faster speed, and yet still negative. So our motion map we have starting far over to the right with some small arrows that point to the left. Then it stops, so we have a couple dots that stack, and then the object resumes its motion but at a faster pace, so these arrows still are to the left but longer. Alright, with the velocity time graph in the next example, we are told here that the object starts with no velocity, so we don't know where the object is, but wherever it is, it's not moving. And then you can see this big gap here, so we are moving quickly to the right, and then slowly back towards the left. Alright, so we have to choose a spot to begin our position time graph. Since the object's going to move to the right, then it's okay for me to start this graph at the origin, because my graph is only going to go up from there. Yet, for the first, if I do choose to start at the origin, because it's not moving, then there's going to be some period of time where we draw our horizontal line on the t-axis to show that the object is at rest at the origin. But we chose to start here at the origin out of just our own preference. I could have started it up here and had the horizontal line at some positive position, and there would have been nothing wrong with that. It's what's to follow. So now the next piece, I want to show that it's moving in a positive direction very quickly, so I'm going to slope this guy steep, right, as compared to now the next portion of the motion, which shows that the object will move at a slower pace in the negative direction. So our graph is going to come back down, but not quite as steep. So again, this general shape, if shown, shifted upward, would look exactly the same. And so if the only thing that was different is the different intercept, then that would still be acceptable. But since we chose to start at the origin, then our object starts here on the far left, and we're going to stack a couple dots right at the origin for time to pass where we're not moving, and then we're going to quickly move to the right with some large arrows, and then return backwards slowly. And so that's our motion map. Alright, now on the back we have we're given new descriptions of motion. We begin with a written description, and we have to derive the two graphs and the motion map. And in the second example, we're given the motion map and asked to write down the description and the two graphs. So reading this example here, it says that the object moves with a constant positive velocity for 4 seconds, then it stops for 2 seconds, returns to its initial position in 2 seconds. All right, so let's take the position time graph first. So we have an object. Now we don't know where the object is, so we're just going to, let's assume that we're going to start it at the origin, because he's going to move in a positive direction, so that's fine. Now for 4 seconds he's moving at a constant velocity to the right, so our graph is going to go up. And so we can even say that this indicates 4 seconds here. Now it stops for 2 seconds. So there's a period of time now that's 6 seconds. Alright, where it stopped. And keeping this interval the same in the next 2 seconds, it returns back to where it starts. So it should be clear that the graph is much steeper. Alright, so not quite as steep, no slope, and then steeper going back down. So that gives us some idea of how to draw the velocity time graph now. We know that it's going to be moving to the right, constant velocity for 4 seconds. It's going to drop for 2 seconds to 0, and then because it's moving quickly, it's going to be negative and constant, quickly moving back to the origin. We're going to start, because we chose to start at the origin, we're going to start to the far left, show that for 4 seconds, that's at time 0, it's going to be moving constant velocity, so same speed. So this is 1, 2, 3, and now at 4 seconds is where it stops, and it's still stopped at 5 seconds, and at 6 seconds it begins to move back towards where it starts at a faster pace, and you can see that it's returned back to where it starts. Now we're given the motion map. This motion map shows that we're starting with some positive position. The arrows are longer, so it appears as though it's moving faster. It stops at the origin and then moves back at a slower pace. So our object is starting away from the origin and moving towards the origin. Actually, I'm going to bring this guy a little bit closer. I'm going to bring him to the origin. So steep this line pretty steep to the origin. We're going to go over horizontal line, show no motion, and then we're going to start to move in a positive direction, but not quite as fast, so our slope is not going to be quite as steep. We essentially return back to where we start, so that's about right. For our velocity time graph, large negative slope, so it's a horizontal line below the t-axis, no motion, and then slow positive motion the rest of the way. The last examples we're going to actually show two objects at the same time. I'm going to say that the object A will be in red and object B I'll put in blue. So we start off with a description that object A starts at 10 meters to the right of the origin and then moves to the left at 2 meters per second, and object B starts at the origin, moves to the right at 3 meters per second. So if we try to draw the position time graph for object A first, I'll do it in red. We're starting 10 meters away from the origin and moving to the left at 2 meters per second. So something like this. Its velocity time graph then will look like a line that is below the t-axis, like so. I can do better than that. Let me do horizontal line. Alright, and then for our motion map, we're starting to the right of the origin, and we've got some constant velocity to the left. Alright, but now object B starts at the origin and moves to the right at 3 meters per second. So what we need to show is that B starts at the origin and moves to the right but faster than A. So it'll make B steeper. It's moving to the right, so it's up here, and it's faster than A, so it should be spaced further up. So this gap is larger than this gap, so B is moving faster. And I'll place B down here at the bottom like they show in this example. We'll place the B at the origin, and we're going to draw those arrows longer to the right. So in the last example, A and B, all the arrows look like they're the same length. They're both in the same direction, so these guys have the same velocity. The difference is at time 0, A is here, and at time 0, B is here. So B is ahead of A at time 0. So if we draw the position time graph, A is the one that starts at the origin, so it's a constant positive slope, and it's constant positive velocity. And with B, we're going to show B starting at some position at time 0 that is more positive than A. So he's to the right of A, ahead of A, but the slopes should generally be, as best you can, the same. So these two lines are parallel lines, and because of that, there is no way on a velocity time graph to distinguish the difference between their motions. So this line represents A and B, because if the only thing that they have different is their intercepts, we couldn't tell that anyway from a velocity time graph. The only thing you get is the slope, and their slopes are the same. So there's no difference between the two objects on that velocity time graph. All right, thanks for watching.